Welcome to the new cyber frontier, bringing you the latest news and initiatives that focus on the development of cybersecurity economics. You don't have to be a computer or cybersecurity expert to get plugged in. Your host brings it straightforward, asks the tough questions, and brings the cyber world to a level of understanding for everyone. You can find us on the web at www.newcyberfrontier.com. Now join our host as he introduces the topic for today's New Cyber Frontier.
Welcome to today's episode of New Cyber Frontier. On today, we have our guest, Slade Griffin, who is the president at Contextual Security Solutions. A long-term friend. We've known each other for years, met back in early 2000s or mid-2000s, I think, and some of the smart grid interoperability programs. I know you worked for Internex. Give us a little bit about your background.
Yeah, thanks, Chris. Great to catch up again. I know we talked on the phone a few weeks ago. I want to think it was yesterday, but it was really probably a month ago. That's how fast time clips by now. You mentioned the mid-2000s. You're dating both of us a little bit. You mentioned before we were both in the Navy from 91 to 97.
Yes.
You were a little bit more of a nerd than me, I think, in the Navy, and have maintained that at this point. So you were a nuke. I was communications radioman guy, which my job doesn't exist anymore in the Navy, and yours does. After the Navy, I got into taught public school for a little while at a VOTEC center. Didn't really love the environment, loved the kids, didn't love public education, left that to go work, become a network engineer in higher education, started with desktop support, then moved to network engineering. Somebody somewhere along the way said, we're going to build a security team. Do you want to do that? I said, man, that sounds fun. And went to a SANS class, I think, that was taught by Rob Lee or Ed Scotus or both. And I was hooked. Now I'm in cybersecurity, left higher ed, left University of Tennessee in like 04, 05 timeframe, went and became a penetration tester as a consultant. Realized I wasn't actually working very hard at the University of Tennessee. Wanted to quit that job within the first 2 weeks, but glory to God, I decided to stay. And it's been a great career ever since then, just working as a consultant, doing security services, had my own company for a while, worked at Internex, like you said, electrical engineering firm. That smart grid was coming out. Nobody knew what that was. Hey, let's make all these power devices talk. And immediately people were like, hey, and then we can get data on the internet. And people like me were, oh, let's not do that. And it's just evolved ever since then to being in those projects with you where you're really focused on things like distributed energy and how are we just going to get power to work from one point to another, to me looking at it from like, hey, how are you transmitting that data and where does that device sit logically in the world, and can anybody in the world touch it or just us? Been finding a lot of hate to throw this out there. I've been finding a few AMI collectors on the internet lately, and you can SSH directly to them. And you're like, well, maybe not a good idea. But
well, I know one thing I saw in your background, a sociology focus or degree, right? How does that apply to the technical and the cybersecurity?
Man, very little. So I was working at the University of Tennessee, and I decided, hey, I still have never completed a degree. So if I could borrow one of yours at some point, that'd be great. But I decided, I'm going to go finish this. And I hate to say this because I'm not saying anybody's smarter than someone else, but I was looking at like, hey, what looks the easiest? Okay. And this is just a numerical fact. The most athletes sign up for criminal justice and sociology. And so in my head, and I'd been a college athlete before, so I was like, I'm going to do that. And so I went and I took a couple sociology classes, and man, they were interesting, bringing up some of the things to debate, social issues among people. And I think the thing I found most interesting about it, which has actually served me, is that people will really get entrenched in defending their position, especially a social position.
Yeah.
And sometimes your personal feeling can maybe overshadow some actual data. We were talking before we both came on about political parties and how we just don't trust really either one,
Hmm.
and I think that's kind of the good position now. Like,
Yeah. Well, let's take a
hey,
break, hear from our sponsors. We'll be right back in a minute.
Blockframe Technology offers next-generation blockchain managed trust and security. Unique non-fungible tokens are used to secure software bills of materials to provide data quality and security for every transaction in your supply chain. Deploy advanced peer-to-peer product security, scale zero trust capability to millions of IoT devices, allow vendor tracking and accountability, and rapidly reset from compromise. Unchangeable, time-sequenced blockchain data provides next-generation security using machine learning trust algorithms and audit analytics. Start securing your supply chain today by contacting Blockframe at www.blockframetech.com.
Welcome back to New Cyber Frontier. On today with Slade Griffin. Before the break, he was talking about his background, and I pinged him about the sociology. I actually thought, a lot of times the soft skills missing in security that might have been a big key benefit to, things I've seen you involved with. And I think I think it is, that knowing, and like you said, entrenched positions, because I think that's a lot of what we're seeing right now. And I think we talked about, covering renewable energy and is it effective? What does, we've been working on this for, 15 years or so. Where's it at now? And what's the effectiveness of what we're seeing in that direction? And entrenched positions are a big thing, I think, with that, because we've had a political push to move to renewable energy just by throwing resources at it. But how effective is that? Where do you see that, sampling? Where are we at right now? Give us your thoughts there.
Yeah, it's a good question, and I think we've got to back up and look at, okay, let's talk about the whole idea of renewable energy. Okay, we've got some natural resources that some brilliant people have figured out how to harness and turn into that light being on. That is amazing. That is, to me personally, that's a gift of grace. What I would call common grace. It that boggles my mind that someone was smart enough to figure out how, hey, there's a flowing river here, and I can make it spin this turbine, and I can make that turbine deliver energy somewhere, or wind, or photovoltaic, solar. And so I think they're phenomenal ideas. And then I remember when you and I were working on some of the smart grid interoperability, and particularly in volt var, and having making sure that you didn't have too many dips at the ends of an electric run or something. How could you stabilize that? And people thought, well, microgrids, and what would those microgrids be made of? Well, you're not going to put a reactor in someone's home, so we'll take that off the table for now. Maybe in 10 years we'll figure that out. We'll have the Mr. Fusion from the Back to the Future, right? But not now. We're not going to do that now. But hey, people can do solar. And so that became the first idea. And there were some pilot programs. I think particularly in Colorado, some of your energy providers would do a tax credit, help you install the solar on your home. My sister did it there in Denver, and it turned out, she actually didn't care for it.
Mm-hmm.
It turned out to not benefit them either in their bill or anything tax wise. So I don't really know why that worked out. I wasn't local to there. And I should say that, my sister is actually a very progressive person. So I'm way over on I'm super conservative and she's super progressive.
Mm-hmm.
And we both were able to sit there and agree, hey, this wasn't an effective solution the way it was tried to be implemented here. Then I think microgrids kind of matured a little bit, and they said, we actually need to have a designated production facility. So they're built it on an acre or two field instead of maybe trying to get it out of people's
In the
houses.
house. Yeah, I think the house thing, and I remember evaluating it when it first came out with all the tax incentives, and it was going to take me like 16 years of my current usage to pay for the whole system with with over 50% tax incentives and credits and local incentives. And then some of the equipment had an 8 to 10 year lifespan, and the degradation in the solar cells didn't last 16 years. They got less power over time. So the whole thing economically had some problems with at that small scale for house. But then at the same time, there was a big, and I've looked into this quite a bit in Colorado, there was a big thought that that would raise the value of the house. And for some reason, it doesn't. Now I've heard real estate agents attribute that to
Mm.
that it's because people are in and out 5 years, a lot of military, a lot of affluent people in those areas, and it doesn't do anything for them because there's other houses in the market for their 5 year or horizon. It's cheaper to not have it, so it doesn't. They can't ask for more because they have it, and that was the best I heard about it. But overall, it just didn't seem to line up to make it economically feasible.
Yeah, so I want to look at two things. I want to look at the economic feasibility real quick, and then how about we also look at like, does it provide the power that was,
And
equivalent
that's the
power?
part I haven't looked into.
So economic feasibility. I just so I live in a 1,500 square foot house with a 1,000 square foot building in the back. I'm southern facing.
Hmm.
I had no, the back of the house faces south, one story. I can easily power the entire house with solar on a sunny day for all of
Hmm.
our needs. So just three of us live here. My other two kids have moved out, and so similar. I went to Signature Solar, I think is the name of the website, just to throw one out there as an example, and I priced it out.
Hmm.
It was going to be if I installed it myself. So if I figured out how to do all the inverters and do all the wiring and drill all the holes, it was going to be between $20,000 and $25,000 to purchase everything. And then I started looking at what is, what's the obsolescence plan here for, like you said, longevity. So the solar panels, I was getting anywhere from 5 to 10 years, but a 10-year max
Hmm.
on the panel itself. And then I was looking at the battery, and there was no good data on how long the battery lasts because the batteries are kind of a new tech. But then the space for the batteries in my garage was going to be that wasn't going to work. So
Hmm.
immediately I'm like, I can't do the whole house. So maybe it's just an array. Then it wasn't working. But long story short, to recoup the costs, I would be replacing the panels long before I would recoup the cost. Um, and it wasn't economically feasible. I couldn't do it, and that's
Yeah.
installing it myself.
Uh-huh.
So, do I think it's a great idea and it's a modern miracle? I absolutely do. Does it work for me economically? It doesn't. Does it work for other people? I'm sure it does. If you can afford to put it in, and you can afford to replace it, and you don't care if there's an ROI, and
Hmm.
it's just a
Well, if you
power
live out
saving
like in the
initiative.
country where you need the power, like your grid's not strong enough, or, when I lived up in New England, Maine had a lot of places that were totally off grid and there
Oh
was no
yeah.
power infrastructure. And these big houses were totally renewable energy, totally sufficient. And that worked because the cost of putting in however many miles of cable or wire was more costly than the infrastructure locally. But when you're on a grid in a tight neighborhood plan, it's a different story.
Yeah, it's just it's tough, and if it's just an ethical decision, again, back to the sociology thing, fine, that's great. I'm so grateful we live in a country where you can do that.
Yeah.
And it isn't the government telling you yes you can or or no you can't. We're not having that argument. You're free to do it if you want,
Hmm.
and that's fantastic. So super grateful for those things that they exist. But for me, doesn't work, and I
Yeah.
would love for it to work because free power from the sun is amazing.
The
It's
other
just
thing is
amazing.
the wind, right? So we drove down to Texas a couple weeks ago to see the solar eclipse, you know, so
Ah,
we were right under the path. And driving across all these big, wide open landscapes, there's now windmills everywhere, right? Windiest day I can ever remember. My bed of my truck is blowing open with the flat thing I have on the bed to keep all
oh,
the stuff underneath. And I've never had it happen before because it's hitting the side of the truck and blowing it up in the center. Anyway, terrible wind. And 50% of the windmills aren't turning.
right.
So there's an infrastructure problem going on where we have all this equipment and now we've thrown it everywhere and we're not using it.
Not using it, and of course, the root problem there is we don't know how to store energy, right? There's all kinds of things out there, and we know the modern battery. is not great.
Mhm.
In any iteration, the one in your car, the car battery in your car, 20 years. So I'm an old guy. I'll just put that out there. I'm 53. 20 back when I was a kid walking to school uphill both way in the snow, your car battery could last a decade or more. Your modern car battery lasts 2 or 3 years now if you take perfect care of it. It's designed to fail. Energy storage is a battery of some sort, right? You're charging up something with capacitance, and how it's going to be discharged is, again, you'll get down into the weeds of double E with that, but doesn't matter. We're not very good at it right now. And so when you go out there and you see these windmills not spinning, it's because they either don't need them spinning or they can't store what's there.
Or they can't take the power far enough away from where they're in the middle of nowhere.
Correct.
To get it to a usable city.
Yeah, it's somebody needs it right then and they can't get it there, right? And that's partially, or who's going to get paid for it and how are they going to get paid for it and how are you going to meter it? There's problems to solve there that people could solve if that's what we focused our resources on. But I think we're more focused on getting them out there and getting them ready. And then you're running in there the same thing that happens with the solar, which is those motors are burning out pretty quick, a little quicker than I think the shelf life was predicted to be. I've seen some things about fires on them. Several workers have died kind of tragically on those trying to work on them, and seen some kind of heartbreaking stories about that.
So it's a new high risk industry for workers too.
Yeah, and then let's move back to the aesthetic.
Okay.
If you like looking at those, I'm sorry. It has ruined the vista for me in so many places of this giant thing that is not functioning. And then they're everywhere. You drive through Illinois or Indiana and you get to an open space and they're everywhere. If I drive down 75 South, I will see a good 3 miles at one point of solar panels. It's about 2 or 3 miles long, and it's probably a couple hundred yards deep, and that's a significant solar array. But yeah, it doesn't make the countryside look great. And again, it's not really doing what it was kind of promised to be. It's not lasting long enough.
Have you seen any effectual numbers on, here's how much infrastructure we put in and here's what we're getting out of it?
I have not, and I would love to get that quantified, especially when we were first seeing this. The number I heard from a few electrical engineers, obviously not scientific source, but was, when we're looking at renewables, whether it be hydro or solar or wind, we're at about a third of the efficiency of a fossil fuel. Say, and we know there's downsides to a fossil fuel, if you want to call it a fossil fuel, but burning something, and so there's a hit right there. Whether or not that's been improved dramatically in the last 10 years, I don't know, but with what I'm seeing as far as the last couple of years, with some of the rolling blackouts that are having to happen, with even our own TVA saying, hey, be careful of your energy usage this coming year when it's really cold or really hot. We're starting to see that in Tennessee now. So we didn't see that before, and I have to think that's because we're shuttering certain kinds of energy production and trying to replace it with others, and they're just maybe not able to keep up. And ironically, for the when it's really cold, we don't have a renewable that's going to function well when it's really cold. So solar, if it's really cold, it's probably overcast. It may be snowing. The panel may be covered. Whatever water should be flowing may be frozen or maybe hard to keep up with. And then it's hard to tell.
Yeah.
So
let's take a
it's
break.
hard to tell.
Let's take a break real quick here from our sponsors. We'll be back in a minute.
Blockframe Technology offers next-generation blockchain managed trust and security. Unique non-fungible tokens are used to secure software bills of materials to provide data quality and security for every transaction in your supply chain. Deploy advanced peer-to-peer product security, scale zero trust capability to millions of IoT devices, allow vendor tracking and accountability, and rapidly reset from compromise. unchangeable, time-sequenced blockchain data provides next-generation security using machine learning trust algorithms and audit analytics. Start securing your supply chain today by contacting Blockframe at www.blockframetech.com.
Welcome back to New Cyber Frontier. On today's Slade Griffin, and we're talking about effectiveness of renewable energy, and just things we've seen. I don't think we have any historical or records on yet as how it's effective, but you can definitely see driving down the road what's come in. You can see what's, we're having more rolling blackouts you were talking about. And we saw those in California, in Colorado. We didn't used to have those, we'll just say in our memory. I don't have any statistical charts to put out here, but is there anything else that could be contributing to that other than just the renewable energy? Is it an increase in population usage? I've heard actually, some of the increase in server farms and usage is tremendous, and is actually, even though consumer rates aren't really changing for usage, the industrial and the technological uses is contributing to a lot of that energy change as far as the need.
Yeah, so a couple points there, consumer rates and then population and demand. So certainly demand has increased, right? Population is typically trending upwards over the last several years, whether it be local or national, regional, whatever. We know there are more people. There's more technology, so more high demand. The computer I have sitting under my desk under here has, one of those AMD Threadripper or whatever. And I mean, it's massive. The amount of power this takes. If my power goes out, my UPS will last 10 minutes if this machine is on. If I turn it off, it'll run all the rest of the infrastructure, my wireless and routers and everything for 3 hours. So clearly we have more demand than we had in the past. But at the same time, when you couple that with putting in maybe a less efficient production source, you're creating a perfect storm of lack of production, lack of demand. And we started off talking about how does this feed into, I'm a cybersecurity guy, but this is an energy security topic, and a lot of what I
because availability is the key
100%.
in energy security.
And there's some conflation that I've seen in the arguments of like, well, cybersecurity and renewable energy are inextricably linked. And when for an old penetration tester like myself, that's kind of funny because it's all just IP addresses to me, and I don't care if your RTU is on a windmill in a field or if it's on something in a nuclear facility. It's an IP address and it's an RTU, and if it's got a vulnerability, it's got a vulnerability. So that's kind of a static look for me, but unfortunately everything's become so politicized that you can't take a position without saying, well, you just hate, insert your president's name here, and that just isn't a good way to look at this. I think we just have to look at the viability, like you said. Is there more demand? Yes. What's the best way to produce power? Well, right now it's pretty easy to say that's nuclear, and that is the best, most efficient way to produce power. But boy, the stigma that has with it, with a few of the incidents that have happened over time, and to be fair, they're very rare. But when they happen, it's a big deal. When it happened in Russia, that was a big deal. When it happened at 3 Mile Island, that was a big deal. And it's just the Fukushima in Japan, when that happened, the impact is great. If something goes wrong, it almost never goes wrong. But when it does, it's a much greater impact than the windmill catching on fire in the field, for sure. So you're looking at that. And what was the other? So we had consumer demand.
We had consumer demand, business demand, technology increases, and then
100%.
Capabilities.
Yeah. So there's just more servers out there now. And we're all using them. Everything's moved into the cloud. So you have these gigantic data centers that are trying to do this. I am sure if it were possible, people that are making these giant data centers will be using as much renewable energy as they can, that if they can build it out for free to lower those costs on some of those things. And they may be doing that. That may be happening. Again, it's kind of, I'm just looking at what I see with my eyes and what I'm seeing in my bill. You mentioned rates aren't going up, consumer rates. I think that is starting to trend up a little bit. My electric bill jumped a pretty significant amount for the first time
Hmm.
ever in the last 18 months.
Yeah,
Um,
I saw that during the end of the pandemic too, when everybody was at home and consumer rates changed. And then, with I think a little bit of inflation the last couple of years, we've seen that. But
it was a
yeah,
it's a huge
when I
hit
said rates,
if Walmart.
yeah, I was actually thinking the number of consumers aren't really changing drastically. We don't have a big population boom. So it's either got to be we're using higher power, uh, like electric vehicles is a part of that. In California, they have a big problem with the current grid in supporting more than like 15 to 17% of electric vehicle penetration.
Mm.
And the amount of grid required changes to make that possible beyond that 20% or so would be almost a redo. So,
Oh, yeah, the EV thing is, again, we're back to the battery. Okay,
mhm,
so when you try to charge a battery, your laptop or an EV, obviously the capacity you're going for there is different. But you go to start to charge a battery, the amperage draw is enormous,
mhm,
and you're just pulling all this power into a single place. So think about the battery in a vehicle versus the battery in your laptop. Uh, you're just really just going for a lot more. So you start to saturate a market with that. It'd be
mhm.
hard to keep up production with the older technology, let alone the newer technology. And we're really going to be forced to look at things like, I think people are starting to explore hydrogen again.
Mhm.
That
Fuel
that
cells
that
and
got
whatnot.
that got a bad rap because I don't know if you remember, but it was one of the, I think it was George W. Bush that said that was going to be the key to the future was hydrogen power.
Mhm.
And because of whatever political party he was in or whatever recent political gaffe he had made,
It shifted.
that
Yeah.
that good idea gets labeled as, well, a dummy said it, and it's just like, well, dummies
Yeah.
have good ideas too. Okay.
That was that
So
party and they don't know what they're talking about, or
correct. And
they
it's
have an
like,
agenda that's trying to destroy our country in this way. Yeah. And every other, every change is just
he's
shifting
a
the other
threat to
direction.
democracy. Okay,
Yeah,
maybe
exactly.
maybe he is, but hydrogen power still is great. Okay.
so
uh
so now I hear everything we're talking about, and I'm just trying to draw the conversation back to security. Are we really, is security a problem? Are we missing something that needs to be there? What, where is it, or is it just literally these infrastructure pieces?
yeah, so I'll look at it two ways. We'll look at security as the availability, first of all. Is it going to
Hmm.
be there when you flip the switch? I mean, that's the definition of a utility, right? The faith we have in our electric company and water company and phone company, EMS, critical infrastructure.
Hmm.
If you dial 911, you believe help is coming. It's there. If you turn your light switch, you page your bill, you believe it's going to be there. So availability, we're already seeing some impact there. I have had we've had a huge influx of people to Knoxville, Tennessee, and I never used to have power outages here, and my power was out at least 12 hours last year.
Hmm.
I've had at least two extended power outages this year, and by extended I mean 3 hours or more. Never used to happen in my neighborhood. So they're
Hmm.
building another substation right over here now. So now I'll have two feeds, and that will solve that, because it's car wrecks and trees blowing over and
Hmm.
that's happening because there's more people. The trees are blowing over because they built, they cut out and built more over there. So there's the availability aspect, and then on the cyber security aspect of it, these are all interconnected devices, and how you're getting that data from one point to the other and how you can impact it, that remains to be seen. So we do some testing of those things. We do a lot of substation audits where we're looking at what we can see. We get into a small utility. We start, what can you see from there? There is currently, these AMI collectors, for example, being on the internet. Well, if your AMI implementation is cloud-based, which several are, um, nothing wrong with that, but you are making it public. And so you will have to defend that well. So
Hmm.
again, when I say you can SSH directly to something, there's a temptation to say, well, SSH is encrypted. That's fine. That just means you can't see the data that's in the stream. That does not mean you can't send a denial of service to that, or
Mm-hmm.
an exploit comes out later that you can take advantage of. And then if
Mm-hmm.
you start manipulating AMI collectors, you're really just manipulating metrology. But if you could move from an AMI collector to, say, a recloser, then that would create, further problems, or somewhere else in the organization, maybe there's financial impact at that
Mm-hmm.
point if all those networks touch, um, and there is no
So
segregation. So
is
certainly
that
there's some
the
impact.
the problem I mentioned, like driving through the vast openness and half the windmills aren't turning in the windiest day. We can't use the power because we can't communicate and negotiate it. So it's a communications infrastructure to fully utilize it. So a logistics problem, and maybe we need to spend our money on building out that instead of just throwing more windmills and solar cells out.
Yeah, and there's the profit question and the infrastructure question. So who gets the money when it's spinning,
Uh-huh.
and how much? And I'm a free market capitalist, so I understand that, but that there is a negative impact right there from that.
Yeah.
Where nobody's wanting to do that for free. You and I don't volunteer all of our time. We charge people for what we do so that we can buy
Uh-huh.
the places we live and feed the people we love, and serve the people we want to serve with the money that's been given us to steward. So I
Yeah.
understand that. And then how do you get a spinning windmill in Texas on the windiest day to the snowed in people in Michigan, who need it at that moment because something went out there? That that is a tough physical problem to solve. That's a long ditch to dig,
Mm-hmm.
to put a cable in that goes that and bridge it through all those interconnections to get it there.
Yeah.
Um, so it's two problems to solve, and I think that there's a temptation to believe everything's a global or a national problem now.
Mm-hmm.
So Texas isn't solving the problems for Texas, or maybe Texas should solve the problems for Michigan. So sometimes it's tempting to think that way, and it's like, well, how do you do that? What
Yeah.
would that look like? Who's paying for that?
Yeah. So that I mean that's a lot of what like we work on is that logistics high level problem. How do you connect everything and get a view in it? Um, and it sounds like maybe we need a concerted effort at the government level to say, how do we make solve that problem? Exactly like you said, get power from Texas to Michigan when it's needed. And, maybe it's not that far away, but it's definitely from these wide open areas that have the renewable energy to the populated areas, which are growing.
Yeah. Well, let's talk about getting power from anywhere to California. California always needs it. Have needed it for 10 years. And yeah, it is so tempting to say, if the government would get involved and fund it, that's the easy fix. But the government doesn't produce anything that they get paid for. That's tax money.
Hmm.
So that their income is our taxes. So you got to remember that there'll be some impact there if they take it over. And then the argument I always like to use there is like, if you really want the government to do it, when your political party isn't in power, do you trust them with it? Okay. And the answer to that 50% of the time is always no, right?
Yeah.
Because we're
Whatever
so
50% is
polarized now.
not in power, it's no. Yeah.
Because we're
Yeah.
so polarized now. And it's like, and that's where you have to remove that political aspect from it.
So
Of,
how do we make it incentivized? How does it come along if it's not a civic project? Or does it just
yeah,
happen over time? Do we
it's a
set
good
our timeline
question.
out further?
I think and again, I think there's a reason I'm probably not in the government. And I'm not working on the things that Blockframe's working on. And I'm not smart enough to figure these things out. But typically, if you can build something and make it work on a small scale, then you start to look at, is it scalable?
Hmm.
So, the idea of socialism. What does it look like at scale? At scale, it's a little tougher, when you look at nations that have done it. But if you
Hmm.
look at the military, you were in the military. That is a socialist structure. You know exactly what everyone makes. You're going to make this based on how long you've been here, what test you took. You're all going to dress the same. We're going to tell you when to eat. We're going to tell you everywhere you're going to go. It works great,
Hmm.
because the expectations going in. You've said you're going to do what you're told to do, and when you're told to do it, and this is your role in the cog of the machine, and there's no arguing for greater resources. But when they try to scale it beyond that, it hasn't historically worked well.
Yeah.
Um, because you bring in different ideas and different ways of feeling about things. The military doesn't allow for that. You are going to go here, and this is what you are going to do. And that's how it works. So you look at the same thing. If you want to build a physical infrastructure that works, can you build it small and make it work well? For sure. But then how do you get that power thousands of miles away to a state that simply can't produce enough power for the number of bodies that are there? Or hey, we're gonna mandate that no gas cars can be sold here. No gas lawnmowers can be sold here. Honda quit making small engines last year. In the fall of 2023, they made the best lawnmower engines, gas engines. They quit
generators
making them.
Too.
Quit making them in November of 2023. They may have started doing it again, but they sent out a notice to their dealers: we're not going to make these anymore because they can't meet emission requirements in California. So you get the emission benefit if you want to believe that's a benefit. But now what is that thing going to be powered by? It's going to be powered by electricity. You don't have enough. You haven't had enough for a decade. So how do you get that power over there? Nobody's trying to solve that problem. And I don't know how to solve it. And grateful to the Lord that no one's asking me to try to solve it because I can't do it. I think you guys can probably figure it out
I think that's something we're kind of biting and trying to take on a little bit from those first making it work in a small scale and then scaling it. The scaling it out's the second phase. But we've ran over our time, but it's been such a good conversation. I think people enjoy this. But I'd like to kind of, as we close here, anything you want to put out that you need from our listener base, a little bit about what you do, how they can get engaged with you, how they can, engage your services, things like that. Go for it.
Oh, very kind of you to offer that, Chris. Contextual Security is a wonderful group of 9 people that I just have the privilege of working with. We do stuff like penetration testing, compliance audits, whether that's HIPAA, PCI, NIST, critical controls, risk assessments. We'll build a risk assessment for you. And to kind of liken it back to what we were talking about, I want you to be able to figure out how to get that energy from one place to another. And then I want my team to be able to come alongside that and say, this is where it's susceptible to disruption from people who don't have your best interest in mind. And unfortunately, the world just has people like that in it. So thanks for that opportunity.
Sure. How would they reach out? Your website? Give a URL?
Website's a great way to do it. I'm on LinkedIn. I'm pretty easy to find because my name is weird.
We'll link to you in the show and put your website up there so people can reach out to you.
I'm grateful for that. Thank you so much.
All right. Well, thanks for joining today, Slade. And we'll have to do this again because it's great talking to you. But we're going to wrap up for today. So you heard it here on New Cyber Frontier. Thanks again and come back for another show.
We hope you have enjoyed this episode of New Cyber Frontier. Remember to get involved. Often we think that someone else will handle privacy and security in the virtual world, but you are the only one truly in command of your virtual fate. Join our mailing list so we can keep you informed of breaking news and new releases. If you have an idea, if you have a question that you would like to hear answered, or if you want to get involved with our efforts, reach out to us at newcyberfrontier.com. We also encourage you to visit our sponsors' links as they are the ones that really make this show possible. I want to thank each of you for supporting the show, and we look forward to seeing you back for the next episode of New Cyber Frontier.